Hello everyone, welcome back to our channel. So today we'll be doing a very new topic which is time series analysis and forecasting. So time series analysis and forecasting have gained immense popularity in various fields like financial forecasting, economic predictions, weather forecasting, energy management and so on. This is due to its ability to uncover insights and make predictions about future data points from time ordered data. So here we will try to cover this topic as much as possible in this video and the other upcoming videos. So time series data consists of observations collected at regular time intervals. Some of the characteristics involve time series data is organized in chronological order where each data point is associated with a specific time or time period. Time series data is a collection of data points measured or recorded at regular and equally spaced time interval. So examples include daily stock prices, monthly sales figure, hourly temperatures readings, and annual GDP growth rates. Time series data exhibits temporal dependencies, meaning that the value at a particular time is influenced by or related to the values at previous time points. These dependencies can take the form of trend, seasonality, autocorrelation, where the current value depends on past values. So understanding these characteristics are crucial when working with time series data because they help us select the modeling techniques such as autoregressive model, moving average model, ARIMA model. Also, it helps in the identification of patterns and trends in the data. So time series analysis is the process of examining historical time series data to understand its underlying patterns, characteristics, and relationships. The primary goal is to gain insights into the data and extract valuable information. So now let's consider this example of stock prices. So stock prices are recorded at fixed time intervals. In this case, we are considering daily. The data is organized in chronological order where each value is associated with a specific date. Each value builds upon the previous value, creating a sequential data set. For stock prices, this chronological order is essential because it tracks the changes in the stock values over time. Analyzing stock prices as time series data allows investors and analysts to identify trends, patterns, and seasonality. And the trends can include upward or downward trends, cyclical movement, short term fluctuations. So, these patterns are valuable for making investment decisions. Also, time series analysis help in forecasting future stock prices. So we can consider various machine learning or statistical models like ARIMA, RNN, which can make predictions about the future price movements. So now let's go through the components of time series. In time series data analysis, trends refer to long-term patterns or movements in the data, which occur over an extended period. So, identifying trends is essential because they can provide valuable insights into the underlying behavior of the time series. Here are some of the common types of trends in time series data. Upward trend, which is an increasing trend. So, this occurs when the data points consistently increases over time, which suggests growth, improvement, or positive change in the variable being measured. Then there is downward trend, which is the decreasing trend that occurs when the data points consistently decreases over time. It suggests decline, deterioration, or negative change in the variable being measured. Then there is seasonality or the seasonal trend. So these are repetitive patterns in the data that occur at fixed time intervals such as daily. This is this is taken as daily, weekly, or yearly. So these are associated with calendar events or natural cycles. Then there is this cyclical trend, which is also called as cyclicality. So these are long-term patterns that occur at irregular intervals and they are not linked to any specific occasion, festival, and so on. They represent economic or business cycles and may have longer durations. Then we have this flat trend, which is also called as no trend. So, in some cases, time series data exhibit no significant upward or downward trend. So, the data fluctuates around a constant mean value. Then there is a deterministic trend where the trend follows a specific mathematical function or equation. It can be modeled and predicted using some mathematical method. So, here in this example, it follows linear growth with constant slope. Then we have the stochastic trend, which exhibits random fluctuations and doesn't follow a deterministic pattern. This requires complex statistical model to analyze. Then there is smooth trend, which is also called as moving average trend. This is obtained by applying a moving average or other smoothing technique to the data to reduce noise. It helps to reveal the underlying trend by averaging out short-term fluctuations. Now let's go through the seasonality. So seasonality in time series data refers to a repetitive pattern or behavior that occurs at regular intervals. This often corresponds to specific seasons or time periods. So detecting and understanding seasonality is important for various applications such as forecasting, as it allows to capture recurring patterns in the data. So these are different types of seasonality. First one is additive seasonality. In this case, seasonal component is added to the underlying trend and error terms. So the amplitude is relatively constant over time. In the multiplicative seasonality, the seasonal component is multiplied by the trend or the error terms. So the amplitude of the seasonality grows or decreases with the trend. So as you can see these visualizations, the seasonal pattern is added to the baseline in the additive case, while in the multiplicative case, it is multiplied by the baseline. Then we have this noise and irregularity. So in time series analysis, noise and irregularity refers to random fluctuations or unpredictable variations in the data that cannot be explained by the underlying trend, seasonality, or other systematic patterns. These components are often considered as sources of randomness or error in the data. So here is a brief explanation of these two plots. So noise is the random and unstructured variation in the data. It represents the short-term fluctuations that are not attributed to any systematic pattern or trend. Whereas irregularity is similar to noise but often refers to larger or more unpredictable deviations in the data. So these deviations are often isolated and not part of the recurring pattern. Then we have seasonal decomposition of time series, which is also called as SGL. So this is a technique used to break down a time series into its key components: the seasonal, trend, and residual components. This decomposition helps in understanding and analyzing the underlying patterns and fluctuations in the data. As you can see in this graph, we use seasonal decomposition to break a time series into its key components. The first one is trend, then there is seasonality, and the third one is the residual component. So here, the second graph, this trend graph, it shows a decreasing trend. This means that the data in the second graph is displaying a clear long-term trend in which the values are consistently decreasing over time. So here, the third graph shows seasonality in stock prices occurring every 2 years. We can observe that from December 2018, which is here, to December 2020, this one here. The seasonality curve exhibits a distinct pattern. However, this pattern repeats every 2 years. So, the seasonality in stock prices can be influenced by various factors, which include economic and market conditions. So, the next plot then is this residual component graph, where the data appears to exhibit random fluctuations, irregularities, or noise. So, in the next video, we will implement the Python code to understand the concepts that we have learned in this video. Please subscribe if you liked the video. See you in the next video. Thank you so much.